When ordering fractions, we need to think about getting the fractions normally so that we're comparing like with like. And the skill that we do that with in maths is called equivalent fractions. When you're presented with problems in this ordering fractions activity, most of the time there'll be one or two that stand out as being either the biggest or the smallest fraction, and you can get those in the right place straight away. If we look at this example, we've got 8/9, which is nearly the whole thing. 8/9 is nearly the whole. 5/6 is also nearly the whole, so we're not too sure yet maybe which of these is biggest. 2/7 on the other hand is quite small. It's much less than half, isn't it? Much less than half of the sevenths. So we know that this one is going to be the smallest of the fractions, so we can put that one down here in the first box. Then we're left with these other two fractions, and to find out which one is biggest, we're going to use a skill of equivalent fractions. Equivalent fractions means we need to get them over the same denominator. We've got ninths and sixths, and it's hard to compare ninths and sixths, but what we can do is find a times table that has got ninths and sixths in it. In that case, what I find the easiest way is just to multiply those two together. So 9 times 6 is 54. Okay, so if I just open up a piece of paper here, we can create two fractions now that are going to be out of 54. 54 on one side and 54 on this side. Okay, and all I did to get that 54, just to remind you, I just multiplied those two denominators together. 9 times 6 is 54, and put it underneath. Then we need to think to ourselves, well, if we've times these together, to get to 54, we had to times 9 by 6. So we've also got to times 8 by 6 as well. 8 times 6 is 48. Okay, and we've turned that fraction 8/9 into a new fraction that is the same as 8/9. We did that by timesing both numbers by 6. 9 times 6 is 54. 8 times 6 is 48. So this is still the same fraction. It's equivalent to 8/9. Okay. We also need to do the same on this one. To turn the 6 into 54 this side, we timesed it by 9. We did 9 times 6 to get 54, so we have to do 9 times 5 to get 45. Okay, once again, we made an equivalent fraction because we timesed the denominator and the numerator, both numbers, by 9. So it's exactly the same fraction, it's just an equivalent fraction. Now we've got two fractions that are equivalent to these, and we can see that they are over the same denominator, which makes it much, much easier to see which one's biggest, or smallest in this case. We can see that 5/6 was equivalent to 45 54ths. 8/9 was equivalent to 48 54ths. So 5/6 is very slightly smaller. So we can go back to our activity and we can put 5/6 in the middle, and 8/9 is the biggest fraction. I'll do one more of those because it's a little bit tricky to understand sometimes. We look at our three fractions. We can see that this one is 2 out of 5. It's less than half. This one's 2 out of 3. It's more than half, but it's still in the middle. 8/9 is nearly a whole. So I think 8/9 we can work out is going to be pretty close to the top here. To quickly work out which of these two is biggest, if you weren't sure, hopefully you'll be able to see, because one is fifths and one is thirds. And if you've got 2/5 which are smaller, it's probably going to be smaller, because thirds are quite big chunks and it's probably going to be bigger. But if you didn't know that, let's just use our equivalent fraction activity again. Let's just do another one of these. We've got fifths and thirds, so we're going to do 5 times 3 is 15. Put that underneath one and put that underneath the other. 15. To turn 5 into 15, we timesed it by 3, so we've got to times 2 by 3 as well. 2 3s are 6. And to turn 3 into 15, we timesed it by 5, so we've got to times 2 by 5, which goes up to 10. We now have two equivalent fractions which we can clearly see which is bigger. 2/3 is 10/15. 2/5 is 6/15. 6/15 is the smallest, then 2/3, and then our 8/9, which we've already put in place because it's clearly nearly a whole. And that is the way to order fractions when you don't have the same denominator. You need to use your equivalent fractions as I've just shown.